Paleogene greenhouse ice-house transition is a hot topic, but while we learn every day more from the ocean proxies, the terrestrial climate evolution remains far less constrained. Some paleovegetation reconstruction have suggested that the greenhouse ice-house transition could have been primarily associated to a winter cooling and an increase of temperature seasonality. This is an important point because winter temperature may be particularly limiting for vegetation. The problem is that land temperature evolution and its intra-annual variability has been barely modeled. Therefore, we decided to compile data recording seasonality change and to model the evolution of seasonality in response to the major forcing documented from the mid-Eocene to the early Oligocene, to get how and why temperature seasonality evolved through the greenhouse ice-house transition. PCO2 lowering results in latitudinal change with both the formation of increasing and decreasing zones. Antarctic ice sheets have a direct negative effect on southern latitude seasonality, but the sea level change it provokes results in the formation of many seasonality strengthening zones. Together, this forcing allows us to produce the first global map of temperature seasonality change across the Eocene-Oligocene transition. Our results are correlated to estimates made by the data, and they suggest that seasonality strengthening took place first at high latitude and in coastal areas in response to mid to late PCO2 lowering and the early Antarctic ice sheet volume fluctuations, and then across mid-latitude in response to major expansion of the Antarctic ice sheet during the early Oligocene. A nice question is, may this seasonality change have had an implication in the biotic crisis of the Eocene-Oligocene transition? We can wonder if it's because they were not affected by a winter cooling that the area of decreasing seasonality, like the US, Patagonia, or Austria, were not that affected by the Eocene-Oligocene transition. Thanks for listening.